Okay, good day. This is Math 140 College Algebra. I am Professor McCulley. This is lesson 1.7 on linear regression. So let's get right to it. Today we are going to create scatter plots and discuss correlation. Students will use a graphing calculator to find a regression line of best fit, and the students will use the regression line to make predictions. If you have taken or are planning on taking Stats 150, or excuse me, 130, then you will have seen a lot of this stuff already, or you will see it. So data in the line of best fit. And so in the quote unquote real world, most data will always contain some sort of error, whether it be an error in the plotting, an error in the collection, or just general errors. If we were measuring the heights of two people that were exactly the same height, we wouldn't expect them to have exactly the same foot size or the same distance between they held their hands out to their sides all the way, the same distance between their hands, or the same waist size. Just because they're the same height doesn't necessarily mean that they would have the same waist size. But that doesn't mean that we can't make some predictions based on that particular um, information. You would expect someone who's taller to have a larger shoe size. The shorter the person, you would expect them to have a smaller shoe size. And so we can certainly make some predictions based on different attributes in the quote unquote real world. All right. So what regression does is it attempts to take in all of this into consideration, and with the understanding that there is error, make a line of best fit that corresponds to the data so that we can still say something meaningful. All right, so scatter plot, graphing points of data, correlation, points of data that seem to show a trend. In this setting, we'll be talking about linear correlation. Positive correlation means that the data tend to rise as we go from left to right. Negative correlation tends to mean that the data tends to fall as we go from left to right. And again, this is all for linear correlation. And then no correlation would be completely random data. So if I have a couple of diagrams here, this set of data here seems to be positively correlated, at least to a little bit, and you could see that there's no way, if I took my line tool, there's no way I could draw a single line and hit all pieces of data. But in general, we can say that this data tends to go up as we go from left to right. And similarly, um, we can say something about this data. It tends to go down as we go from left to right. And again, we couldn't necessarily draw a line that hits every single piece of data, but in general, it falls from left to right. Now, data with no correlation is going to be completely random, and we can have correlation that's nonlinear. And so if I had a set of data that went like that, I might say that it has quadratic correlation. Um, but that's not the focus of this particular lesson. So let's talk about the process of finding the line of best fit using a graphing calculator. And excuse me here, I gotta blow my nose for a second. Oh, that was kind of miserable, and I'm sorry. So steps for linear regression. The TI 83 and 84, you're going to clear your list by hitting the stat and then clear list. You're going to clear list 1 and list 2 because we're going to make list 1 our set of x values and list 2 our set of y values. We're going to hit our data, and so we're going to enter our data, and we're going to hit stat, and then we're going to hit the edit key. And we're going to open our window to fit the data, whatever that is, and we're going to use the window key to do that. We're going to turn on our stat plot, which is the second and then the y equals key. We're going to graph our scatter plot. That's optional. And then we're going to use the calculator to find the line of best fit. We're going to hit the stat, the calc, the linear regression, ax plus b, and then we're going to use L1 and L2 and make sure we'll hit enter. So L1 is going to be our x list and L2 will be our y list. We're going to graph the equation, and then if we need to, we're going to use the function value function to make a prediction, and that's second trace value. So let's look at the graphing calculator and we'll do some of these things. But before we do anything, if you have a TI-84, we want to make sure that we're turning on our regression capabilities. And so you want to hit the mode button and you want to go down here and you want to make sure that the stat diagnostics are set to on. Now, if you have a TI-83, it takes a little bit more work, but we can do that. So if you have a TI-83, please ask me in class, and I will make sure that your stat diagnostics gets turned on. All right, once we've done that, we're going to enter our data. So the first thing we want to do is we want to find a set of data. And our first set of data here is this set here, and it's an example. And so our X list is going to be 2, 4, 6, 8, 10, 12, 15. Our Y is going to be 6, 11, 21, 30, 31, 35, and 50. And we're going to enter that data. So the first thing that we want to do is we want to quit out of this, clear out everything. And the first thing we have to do, if I go back to my list of things here, we need to clear out the list that I had. Don't know if there's any data in there, but I'm assuming that there is. So I want to clear out any data that I had from a previous one. So my stat button is right here. It's right next to your right arrow key on the data pad. And the first thing I'm going to do is clear lists. So I'm going to hit 4, and then we got to tell it what lists to clear out. And if you look at the second feature of your 1, 2, 3, 4, 5, 6 keys, you see L1, L2, L3, L4, L5, and L6. Well, if you hit second and then 1 and then the comma button, which is right above the 7 button, and then second and then 2, we get a clear list 1 and clear list 2. So if I hit enter there, it says it's done. Now I want to enter the data. So I'm going to hit that stat button again, and that's what it says here. I'm going to enter the data, hit stat, and then hit edit. So I hit that stat button. Now I'm going to hit 1, hit edit. You'll notice I have all of these lists here, and there's no data in there. So the data has been presented horizontally. We're going to enter it vertically. And so in that L1, we're going to enter this X list, 2, 4, 6, 8, 10, 12, 15. So we're going to do that. So 2, and then once you enter the 2, you have to hit enter, and it goes down. 4, and then 6, and then 8, and then 10, and then 12, and then 15. All right. So, and then you can use your D-pad here to move around. So if you made a mistake and you said, oh, that was supposed to be 11, you could come down here, type in 11, hit enter, and then you can update that. So you don't have to be perfect, but you do want to make sure that you get all the data in there correct. And then hit 12. And now I'm going to hit my right arrow key. It's going to put me at the top of the second list. And so 6, 11, 21. Let's just do 3 at a time. So 6, hit enter, 11, enter, 21, hit enter. And then the next one was 30, 31, 35, 50. So let's do that. 30, 31, 35, and then 50. All right, and I think I have all of that data in there correctly. Okay, that's awesome. Let's take a look here. It says, all right, turn on your stat plot, and if we want to graph it, we should make a window that's going to best fit that window. So if we want to see this data, the X's go from 2 to 15, and the Y's go from 6 to 50. That's clearly not on a standard window. So I'm going to hit window here. I'm going to start at -2 because I still want to see my X-axis. And I'm going to go to 20 here just for fun. And my Y scale will still be 1. And we need to go to at least 50. I'm going to go 75 here, and I'm going to go by, we'll go by 5s. And then to see the data, we're going to go second, and then we're going to go y equals. You'll see the second feature of the y equals is the stat plot. And we want to plot some data here, and we're going to make it as a scatter plot. So we're going to hit 1. And we want to turn this to on, and we're going to leave all of the default settings. This is a scatter plot, that's a line graph, that's a bar graph, box and whisker plot with outliers, box and whisker plot, and this is a cumulative plot. X list is L1, that's where we put our X's. Y list L2, that's where we put our Y's. Our mark is going to be this box thing, and if I hit graph, we can see the data, plus there's a Y equals from the last lesson. Now again, there's no way I could draw a line along this data and hit all of those points, but in general, there certainly looks like there's some positive correlation in this particular instance. And so what we're going to do is we're going to find our line of best fit in the stat, calculate linear regression. So we're going to hit the stat. We're going to go over to calculate. We're going to go linear regression AX plus B. So we're going to either arrow down to 4 or just hit the 4 button. We're going to make sure our X list is L1, our Y list is L2. We don't have a frequency list. We're going to, this one says store regression equation. If you don't want to type it over, you can just plug it in. So what we can do is it can hit vars right here. Hit vars, go over to y vars, hit 1 for function, and then hit y1. And what this is going to do is it's going to take this linear regression and it's going to plug it in all of the decimal places into y1, which is kind of cool. And we'll see it here in a second. So we go down to calculate, we hit enter, it does that data, does that for us, and so y equals ax plus b. Our slope for this thing is going to be 3.233409611, and it's entered that into your y equals, and we'll see it here in a second. And then b equals to negative, which is so our y-intercept is negative 0.043478, and r is our correlation coefficient, and 0.98 is pretty close to being linear. And without looking up the correlation coefficient, it's clearly, even for 6 pieces of data, this is going to have significant linear correlation. And so if I hit my y equals, you'll see that it plugged all that data in for the slope, and then we can't see it all here right now, but it's in all those values for b is going to be plugged in there. If I hit graph, this is my line of best fit, and we can see there's a couple that are above, a couple are below, and a couple that it hits right on. And so that looks like a fairly good line of best fit. And so just to finish it off, we would put for our final answer, it's going to be y is equal to, and I want to, let's quit out of this. You know what, I'll just run that regression one more time here real quick so I can get it. For enter. There we go. So it's 3.233, y equals 2.233x minus 0.435. 0.0435. That is my line of best fit. All right, let's talk about a real world example. Mr. McCulley likes to predict how fast swimmers will go at their big meet. Over the years, he's compiled a number of swimmers' best in-season time, which I call I, as well as their best big swim time, which I call B. A sample of these is provided in the set below. So part A asks us to write a regression line of best fit for the data, so we're going to do that. And then if a swimmer to go 32.5 is their in-season time, what would be their big swim time? And again, we clearly see that there's some variation here, but certainly after years and years of collecting data, there should be a general trend that we might be able to make a valid prediction of. So let's go through that process again. And the first thing we're going to do, hit stat. We're going to clear out the list. So clear out list 1 and 2. So second L1, comma, second L2. Hit enter there. All of our data has been cleared. And so now I'm going to hit stat, and we're going to hit edit. And I need to be in L1, and so we're going to put our in-season times. I'm just going to do the first 2 here. So 35.4, 33.2. 35.4 and then 33.2 is my first two pieces of data, and then 31.4, 33.6, 31.4, 33.6, and then 29.4, 30.1, 29.4, 39.1, and then the last piece, oh, it's 30.1 and then 39.5. All right, so 30.1, and then that last one was 39.5, 39.5. Now that I have all of that data in, I'm going to hit my right arrow key, and that's going to take me up to my big swim list. So 33.2, 31.0. So 33.2, 31.0. And my next two, 30.4, 32.0. So 30.4, 32.0. And then let's see here, 28.6, 29.0, 28.6, 29.0, and then the last one, 36.8. And I think I have everything in there. So we're going to, if I wanted to look at a scatter plot, I could do that. My X values definitely have to go out. We'll go out to 40, and we'll go by 4s. And my Y values are plenty big enough. So this is my old regression line. Here's my new set of data. And if I want to do that, the new regression line, I'm going to hit Stat, go over to Calculate. We want linear regression 4, and we want to put that data in there. So vars, go over to Y vars function 1, and then we'll calculate. And our R is even bigger, 0.995, and so we don't have to worry about anything with that. It's so close to being linear. And my slope is 0.806, my y-intercept 4.764. In fact, let's do that because that's what it says, write the regression line of best fit. So for part A, I'm going to say B is equal to, and 0.807, 0.807 I plus 4.764. 4.764, and then so that's our data. And if I hit my graph, that looks like a pretty darn good line of best fit. And then if I want to do a prediction, so for part B, if they went 32.5 as an in-season, what would be their big swim? Well, since I have this equation in there, I can go second, and then the trace button value plugs values for x into the function that we've already defined. And since we've already defined it as that, I'm going to go second trace, I'm going to go value, and we're going to enter 32.5. So if a swimmer goes 32.5 in season, when they go to their big swim, they can expect to go 30.98. And in swimming, they only go to 2 decimal places. So we're going to say 30.98 seconds is what we would expect them to go in their big swim time. Well, that's all I got for today, folks. So the Marvel fun fact of the day, the character Taserface from Guardians of the Galaxy Volume 2 has his origins in the comics, where his family comes from a race of people who evolved from the junk that Tony Stark shoots into deep space. No wonder he's so ugly if he lived on junk. Well, that's all I got for today, folks. Have a good day. Bye.